Alrighty, welcome back. Let's delve a little deeper into inverse relations, okay? Because they're easy when they just give you the numbers, but they won't always do that. So let's talk a little bit about the inverse relation theorem, which you need to know, so I definitely suggest writing this down. So suppose F is a relation and G is the inverse of F. So essentially, we're just switching all the inputs for the outputs and vice versa. Then, a rule for G can be found by switching X and Y. I'm going to show you how to do this here in a bit. This is actually really handy and it helps a lot. It's very easy. 2, the graph of G is the reflection image of the graph of F over the line y equals x, which is actually what we just saw in the last example. And then also, number 3, the domain of G is the range of F, and the range of G is the domain of F, which we actually also saw in the last example. So we actually did both of these. We essentially did this one too, but this one works better for equations. So we did both of these. We saw both of these in action, but let's actually see what number 1's all about in the next example. Please make sure you get this whole theorem down, so if you need to pause the video, now would be a good time to do so. Alrighty, example 2 says consider the function with domain the set of all real numbers and equation y equals x squared. So you're probably already thinking to yourself, hey, I know what that graph is going to look like. It's x squared, so it's going to be a parabola. Alright, so we should expect something as such. It says, what is the equation for the inverse? Here comes where you switch the x and the y, and it's actually very, very easy and very, very helpful here. You just essentially literally take x and put it in y spot, and take y and put it in x's spot. So let me get a different color so you can easily see it a little bit better here. Alright, so we're literally going to switch x and y, just their places. So x sits where y is, and then y goes in here, so that means now we have y squared. Okay? So we just switched x and y. But you never leave your function like this because we always see it as a y equals. So we then have to get y back to where it was. Now don't just switch them back because that would just give us the original equation. So that's not very helpful. We have to start thinking along our algebraic rules here and say, okay, I got to get y by itself. So what do I do to y to get it by itself? Well, if I'm squaring here, essentially to undo that, I would square root it or take the half power, whichever you like to do now, because now we know it's there's two different ways to do it. Okay, what I mean by that is y equals x, or excuse me, x equals y squared. See, I do it too. If you want to do the half power to both sides, that's the exact same thing as what I just did over here. Okay, so what happens is the squares and square roots cancel each other, and I get y equals, and then I just have the square root of x, because I can't really do anything with the square root of x. So that would be my equation in root notation. Over here, if I did it with power notation, I would have y equals x to the 1/2 power, which is the exact same darn thing as what I have over here. These are the same thing. Okay, this is just written in radical notation, and this is written in power notation. Okay, but they do the same thing. Alrighty, so it says graph the function and its inverse on the same coordinate plane. Okay, so our original function we already said was going to be a parabola. So we can graph that. That'll be easy. Let's go ahead and I'm going to make a little XY chart here. And we're going to do this one by hand. I know we have a graphing calculator and you can grab that right now if you want to. But I'm going to do, manually. So first point I'm going to do is 0. So I put in 0 for x. 0 squared is, well, 0. Okay, which we should expect because it's a power function. So it's going to go through the point 0, 0. We'll plot in a second. All right. Next point, let's do 1. 1 squared obviously is just 1. Oh yeah, by the way, this is our original function, so y equals x squared. And then we put a 2 in, so 2 squared is 4. And then we'll put a 3 in, so 3 squared is 9. And I'm going to stop there because I'm not sure that that's going to fit, okay? So let's go ahead and we'll go graph this. So let me get my highlighter out so you can see it a little bit better. And let's do darker color. Let's do blue. All right. So let's go plot these points. So we have 0, 0. So that's right here. There's our first point. Then we have 1, 1, which is right here. Then we have 2, 4. So 1, 2, 1, 2, 3, 4. And then we have 3, 1, 2, 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that looks like that's going to be all that fits over here. The next one would obviously be 416, and that's not going to fit up here, okay? So, well, we know this is parabola, so we have this half. Let's go just use symmetry to draw in the other half. All right. If you wanted to go figure out all these values, you can, but we know it's symmetric to the y-axis, so we can just draw it in. Okay, now I'm going to connect it all. Okay, so there's 1/2. Alrighty, not shabby. Okay, so there is our y equals x squared graph. Alrighty, now I could, if I wanted to, go find values for this guy, our inverse here, just like I did over here, except it's going to get a little sticky, because when I'm taking the square root of stuff, I actually am not going to be able to have, well, I can't put it, well, I guess I could put 1 in there. I could put 4 in there, but I'd have to jump around, which, let's do it actually. Let's go ahead and make an XY chart. And then I want you to see that the property is going to reflect along, let's draw on our line first so we can start seeing if it's going to, whoops. Sorry, I'm just trying to think of the best way to do this. I'm going to go ahead and draw in, remember that y equals x line, which goes somewhat like that. Sorry, it's not as straight as the last one, but it should reflect over this line. So if I wanted to, I could kind of do that on my own here. But let's see what happens. So let's get our pen back out here. Actually, let's erase. Sorry, you guys don't have to erase on your paper probably, but I'm running out of room, so let's get rid of all this. And we'll make another XY chart for our other equation here. So, alright. So now we're doing y equals the square root of x. So then I'm going to make another XY chart. Start with 0 again. So if I put 0 in here, the square root of 0 is 0. If I put 1 in here, now be very careful here. If I put 1 in here, if I square root 1, that, remember, I always say you're going to forget this, and I always do, but it's plus or minus 1. Because if I put negative 1 in here, or excuse me, if I put negative 1 in for y, I'd have to square it, and that would be getting rid of this square root here. And I could do that because negative 1 times negative 1 is a positive 1. And that gets me back to x. So I do have plus or minus here. I'm going to skip 2 because I can't take the square root of 2 very easily. Also with 3, I can't do that very easily. Let's go to 4. If I square root 4, that's going to be plus or minus 2. And I'll show you how this works here when we graph, alrighty? And then the next one I can actually square root is going to be 9. So we'll skip 5, 6, and 7, and 8. And I know when I square root 9, I get plus or minus 3 here. Okay? So now let's go graph. Too green. Alrighty. Oh, dang it. Sorry, I wanted the highlighter because it was bigger. Let's change that. The color there. Okay. Alright, we're in business. Alright, so 0, 0. That one's easy. And we expected that point because it was on our line. And then I have 1 and then positive 1. So let's do that first. So 1 and then positive 1 would be right here. Again, I should have expected that because that blue dot was on that line there. And then I also have 1, negative 1 here. So we have 1 and then negative 1 is going to be right here. Then I have 4, 2. So 1, 2, 3, 4, 1, 2. And then I have 4, negative 2. So out 4, down 2. And then I have 9, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. And then I have 9 and then negative 1, 2, 3. Notice this is just a parabola lying on its side, and now it's symmetric to the x-axis instead of being symmetric to the y-axis. And I want you guys to do this. So actually take your piece of paper, fold it along, now it's my yellow line, I don't know if you did yours in yellow or not, fold it along those lines, and those two parabolas, this blue parabola should fold on top of this green parabola because they are inverses of each other. That is exactly why this happens, okay? And for part C, it says, is the inverse a function? Why or why not? So now if you think back to when we first started talking about functions, way back when, alrighty, we had what we called the vertical line test. And the vertical line test determined if we had a function or not. So essentially what it was you can imagine just one of these dark, or light lines here, just kind of doing like a sweep, kind of like an Etch-a-Sketch, or not an Etch-a-Sketch, one of those toys. It was kind of like an Etch-a-Sketch. You use like magnets to draw, and then you'd have a thing at the bottom and you just pull it over and it would erase in a straight line. I hope you know what I'm talking about. If not, I sound kind of like an idiot, but hopefully you do. It's not an Etch-a-Sketch because those you shake, but it's something like that. Forget what it's called. But at any rate, you can imagine like if you had a ruler and you held it straight up and down and wiped it across kind of like a windshield wiper. Do we hit any part of the function twice? If we do, then it's not a function. If we don't, then it is a function. So let's focus on the blue parabola. This guy passes the vertical line test because no vertical line hits this thing twice. And we already know it's a function because it's a parabola, it's a quadratic. We know these. We know that they're functions. Now this green guy, if I drew a vertical line going through this guy, well, right here and right here, it hits twice. It happens all over the place. Here's another one. Here's another one. And they're hitting twice pretty much everywhere we're at. So this guy fails big time. He gets a big F because he fails the vertical line test very, very badly. So no, you would say, is not a function because it does not pass because fails the VLT, which is the vertical line test. Okay, so it's not a function. The original equation is, but our inverse fails it miserably, so it's not a function. Okay, which actually brings me to my next point, which you're going to have to tune into the next video to see. It's something kind of cool here that tells us this before we even do anything. So hopefully you'll join me for the next video. I'll see you in a bit.